Happy day, children. Welcome to the world of physics. Before I introduce today's topic from lesson number 2, forces and pressure, let me ask you few questions. The questions are: when you're on the way to school, you observe many objects around you. You notice some of them are moving and some of them are at rest. Can you stop the moving objects? Can you move the objects that are at rest? Just look at these actions. Have a look at these actions like cycling, hitting a cricket ball, opening a door, and pulling a chair. What is common to all this? Yes, the answer to all these questions can be given by a single word: force. So today we are going to learn about force. So what is force? In your previous classes, you would have studied about force as a pull or a push upon an object. So what is force? Force is nothing but pull or a push upon an object. What are the effects of force? What force can do? Here you see a ball which is stationary, which is at rest. A force can make a stationary object move, or we can say force can move a stationary object. Now you see, this is a stationary object. When force was applied by the boy, the ball started moving. Here we see a stationary ball. When it starts moving, this ball can be stopped by applying force. So force can stop a moving object. Here you see there is a moving ball, and when force is applied by the boy on the ball, the direction of the moving ball is changed. So we can say that force can change the direction of a moving object. Force can also change the speed of a moving ball. Here is a slow moving ball, and when a boy comes and kicks this ball suddenly flies high. So what does this mean? That force can change the speed of a moving ball. Force can also change the shape and size of an object. See this example in which when force is applied on a balloon filled with water, the total shape of the balloon gets changed. Here is a wheat flour dough. When force is applied on this dough, the shape of the dough changes. See, on the whole, we can say that whatever force is applied on any object, it can be measured. So we say force is a physical quantity. It has a magnitude, and always force acts in a particular direction. So force is a vector quantity. And here you see force applied on any object depends on the mass of the object. If the mass is more, we need to apply more force. If the mass is less, we need to apply less force. So the small boy is able to move a 25 kg mass, but he is not able to move a 100 kg mass. Why? Because 100 kg mass needs more force to be applied. And in the second case, you see here, force decides a change in velocity with time. Here you see a small girl kicking a ball. When she kicks the ball, she is able to apply very small amount of force. So the change in velocity of the ball is very less. Okay, but here a big man is hitting the ball, and when he hits the ball, he applies a great force, and when he applies a very great force, the velocity changes at a higher rate. So what is this change in velocity called as? It is called as acceleration. So what we understand by this? That force depends on mass as well as acceleration. And as I said before, all the physical quantities are denoted by a letter. The same way, force is also denoted by capital F. And why is that arrow above it? Because force is a vector quantity. It is a symbol of a vector. So as we discussed in the previous slides, that force depends on the mass and it also depends on the acceleration. So here we can say that force is directly proportional to mass and acceleration, and force can be calculated as the product of mass and acceleration. So force can be given by the formula m into a, as m is the symbol for mass and a is nothing but small a denotes acceleration. So by this itself we can understand that this quantity, physical quantity force, it depends on other physical quantities like mass and acceleration. So force is a derived quantity. Now let us come to the unit of force. As all physical quantities are having a unit to measure, force also has unit to measure. And the SI unit of force is Newton, in order to honor the scientist Sir Isaac Newton, who is a great scientist in the field of physics. So when 1 Newton of force is said to be applied, when 1 kg of mass is accelerated by 1 meter per second square, we say that 1 Newton of force is applied on that object. Now next is the CGS unit of force. The CGS unit of force is dyne. It is denoted by the symbol dyn, and 1 dyne force is equal to 1 gram mass into 1 centimeter per second square acceleration. That is, when 1 dyne of force is said to be acting on an object, when 1 gram mass is being accelerated at the rate of 1 centimeter per second square. And you all know, children, that dyne is derived from a Greek word dynamis, which means power or force. So dyne is not based on any scientist name. It is derived from a Greek word dynamis, which means power or force. See, unlike other quantities, force has a third unit also, that we will discuss after discussing the relationship between SI and CGS unit of force. As you all know, what is the SI unit of force? Newton. And 1 Newton of force, when it is said to be applied, when 1 kg mass is being accelerated at the rate of 1 meter per second square. So 1 Newton is equal to 1 kg into 1 meter per second square. So 1 kg is equal to how many grams, children? Yes, it is 1000 grams. And 1 meter is equal to how many centimeters? Yeah, you're correct. It is 100 centimeter. So we can write it as 1000 grams into 100 centimeter per second square. Seconds will not change because the CGS unit of time also is second only. So when you multiply 1000 with 100, you will get 100,000 or 1 lakh grams centimeter per second. And 1 lakh can be written as 10 to the power of 5. And 1 gram into 1 centimeter per second square, what is it called as? It is given the unit as dyne. So we write it as 10 to the power of 5 dynes. So by this, what do you understand? That 1 Newton is equal to 10 to the power of 5 dynes. Now we come to the third unit of force, that is the gravitational unit of force. And this gravitational unit of force is given as kilogram force in SI system and gram force in the CGS system. What do you mean by kilogram force? See, 1 kilogram force is the force acting on an object of mass 1 kg, which is accelerating at a rate of 9.8 meter per second square. So here the acceleration is equal to the acceleration due to gravity. Okay, so when any object falls vertically downwards with a mass of 1 kg and accelerating at a rate of 9.8 meter per second square, we say that 1 kilogram force is acting on that object. And 1 kilogram force is equal to how many newtons? It is 9.8 Newton. The next is the CGS system of unit. There, the gravitational unit of force in the CGS system is 1 gram force. So 1 gram into 980 centimeter per second square, because the acceleration due to gravity in the CGS system is 980 centimeter per second square. So when a mass of 1 gram is dropped vertically downwards, it accelerates at a rate of 980 centimeter per second square. So you get 1 gram force is equal to 980 dyne. So understood, children, clearly the gravitational unit of force, both SI as well as CGS. Okay. Next is, how can we feel 1 Newton of force? It's very easy, children. If you take 100-gram mass on your palm and hold it parallel to the ground, you can feel 1 Newton force. So, what is the mass you have to carry for feeling 1 Newton force? It is nothing but 100-gram mass. Why 100-gram mass? Why not 1 kilogram mass? 100-gram mass because the acceleration produced on that particular mass which you are holding it in your hand is 9.8, approximately equal to 10 meter per second square. So when you multiply this mass with that, you will get 1 Newton of force. This 100 gram is equal to 0.1 kilogram. 0.1 kilogram into 10, how much you will get? 1. So 1 Newton of force can be felt by placing a 100-gram mass on your palm and hold it parallel to the ground. Okay, children? Now next is the different most concept of force. Very different concept of force, in which we are going to study about resultant force or net force. This term is a new term for you. You all should try to understand that all the objects around us are being acted upon by many different types of forces. So altogether, a single force does not act on an object. Many forces act on an object. So these many forces, when they act on an object, what happens when 2 or more forces act on an object in different directions? The effect on the object is due to the magnitude and direction of the net force acting on it. So here in this object, we just assume that there are 2 forces acting, F1 and F2, and F1 is greater than F2. Then the net resultant force can be calculated as F1 minus F2. Actually, the net resultant force will be the sum of all the forces acting on that object. But since these 2 forces are acting in opposite directions, we will take one of the force as positive, the other force as negative. That is why we get F net value as F1 minus F2. And then you see this situation in which 2 boys named as Ram and Raju, both are applying force to push that box. And this box, when it is being pushed, they both are applying force. Ram is applying a force of 40 Newton and Raju is applying a force of 50 Newton. So since both of them are applying force in the same direction, then what is the net resultant force? As I said, net resultant force can be calculated as the sum of all the forces acting on it. So here we'll calculate the value of net resultant force or total force acting on the box as 40 Newton plus 50 Newton, which is equal to totally 90 Newton. Okay, so the total force applied on the heavy box is called as a resultant force. And what do we conclude here? We conclude that when 2 forces act on an object in the same direction, the resultant force is calculated by adding the forces. It moves the object in the direction of the applied force. So we can calculate F net as F1 plus F2, since both the forces are acting in the same direction. But suppose they both are not acting in the same direction, what will be the result? See, here comes the concept of balanced force and unbalanced force. When 2 or more than 2 forces are acting on an object in opposite directions, then there are 2 conditions possible. One condition, the object may move. The other condition, the object may not move. So in which condition the object moves and which condition the object does not move, based on that, force can also be classified as balanced force or unbalanced force. So what is a balanced force? In case of a balanced force, look here, 2 boys are trying to push a box in 2 opposite directions, but both are applying 40 Newton force on either sides. So the resultant force, as I said, it is the sum of all the forces acting on an object. Here there are 2 forces acting, but one force is in one force is acting towards your right, the other force is acting towards your left. So the sum will be 40 plus minus 40, because you all know force is a vector quantity and we have to take a negative sign for the force which is acting in the opposite direction. So we'll get the answer as 40 minus 40, 0 Newton. So in this case, when the net resultant force is equal to 0, the object will not move, and this type of force will be called as a balanced force. So when two forces act on an object in the opposite directions, the resultant force is calculated by the difference of the forces. So we come to a conclusion that when two forces are acting in opposite directions, the resultant force is calculated by the difference of the forces, and by calculating in that way, if the net resultant force is equal to 0, then the object will not move. Here is an example of a balanced force in which these forces are equal in magnitude but opposite in direction. That is why the seesaw is not moving at all. It is at rest. Next comes our unbalanced force. So what will be an unbalanced force? It will be just opposite to that of a balanced force. In case of an unbalanced force, also there will be forces, two or more than two forces acting in opposite directions. But here you see both of them are applying force, but the magnitude of force differs. One boy towards the left is applying a 50 Newton force, and the boy towards the right side is applying a 40 Newton force. So what will be the net resultant force? As I said, when they are applied in two opposite directions also, the net resultant force will be the sum of all the forces acting on the object. But since force is a vector quantity, we'll take one force as positive, the opposite force acting to it as negative. So 50 Newton plus minus 40 Newton. So 50 minus 40 will get the resultant force as 10 Newton. Here the net resultant force is not equal to 0. Since the net resultant force is not equal to 0, it moves the body in the direction of the larger force. So what conclusion we come to here? When two unequal forces act in opposite direction on an object, the resultant force is the difference between the two forces. Okay, and if the resultant force is not equal to 0, it moves the body in the direction of the larger force. See, on the whole, what conclusion we come to? When forces are acting in the same direction on an object, the resultant force will be the sum of the forces acting on it. And if the number of forces are not acting in the same direction, then the resultant force will be the difference of the two forces acting on that object. Here is an example of the unbalanced force. So in this case also you have seen there was a motion. That is, here you see this GIF, you will be able to see that the seesaw is moving. Why the seesaw is moving? Because it is a case of an unbalanced force where two unequal forces are acting in opposite directions. And then next example is the tug of war. In this case, you see, in case of a tug of war can be the case of a balanced force as well as an unbalanced force. See here, the first case, the two teams are applying 300 Newton and 300 Newton force. So since they are applying both equally, both the teams are applying equal amount of force, so we can say that the force here is a balanced force and the rope will not be moved on either sides. But in the second case, you see, the first team is applying a force of 400 newtons and the second team is applying a force of 300 newtons. So the force will be more towards the first team and the rope will be pulled towards the first team. Okay, so here the tug of war can be taken as an example of both balanced force as well as unbalanced force. Then comes the next type of classification of force, in which forces can be classified as contact force and non-contact force. Based on the physical touch, the force which can be exerted by an object on another object only through physical touching is called as contact force. So, what are the examples of contact force? One is the muscular force. Muscular force, the force exerted by the muscles. Next is the mechanical force. That is, the mechanical force is the force exerted by the engines. And the third one is the frictional force. The frictional force comes into action when two surfaces are in contact, and usually the frictional force opposes the motion of an object. Here you see these actions: a person carrying books, a boy walking, and a person lifting weight. All these actions which involve the force which is resulting due to the action of muscles is known as a muscular force. Even lifting a bucket of water is a muscular force. Cycling is due to a muscular force. Whatever we do with our hands and legs by physically touching any object, for example, lifting a tumbler of water, lifting a box, pulling a table, pushing a chair, all these comes under muscular force. Here you see, in this case, the force exerted by the car engine to move the wheels is an example of muscular force. The tractor also moves by the same way. Here the crane is able to lift objects due to the force exerted by the engine. And you can see here that the motion of the blades of the windmill. The blades of the windmill are able to move, and they are generating power for the generator to generate electricity. This also is an example of mechanical force. So this type of force which is provided by the engines to make the objects do a work is called as mechanical force. So the force exerted by machines to do some work is called as mechanical force. Next, these are all the situations where we feel a force that opposes our motion. While cycling, you'll feel that there is a force which is making us move backwards. While pushing a box, you will feel as if something is hindering your action. While pushing a trolley or pushing anything, you will just feel that there is a force which is acting opposite to the motion of this object. Everywhere, even in air and water also, you will feel this force which is trying to oppose your motion. So this type of force which is trying to oppose the motion of objects, or otherwise we can call it as the force generated by two surfaces that contact and slide against each other. It slows down the motion of objects and prevents things from moving, is called as frictional force. So what do we call as frictional force? Frictional force refers to the force generated by two surfaces that contact and slide against each other, and it slows down the motion of objects and prevents things from moving. A detailed study of the frictional force, we'll be studying it in the next recording. And next comes the types of forces that do not need any physical contact with the object on which they are acting is known as non-contact forces. So those forces that do not need any physical contact with the object on which they are acting is known as non-contact force. So let us see the different types of non-contact force. The first type of non-contact force is the gravitational force. See the boy throwing a ball upward. Always it comes downward. Whenever any object is thrown upward, it comes downward. It is because of the gravitational force. Next is the magnetic force. Here you see the magnet is able to attract the iron nail. Because of which force? Magnetic force. Even though the iron nail was not in contact with it, it was kept a little away from it, the magnet was able to attract. The next comes the electrostatic force. You see a person rubbing a comb on his hair, dry hair, and then he brings the comb near the bits of paper. The bits of paper gets attracted. So what is this because of? This is because of electrostatic force. Let us discuss all these one by one now. You can see the scientist. Can you name the scientist, children, sitting under an apple tree? Yes, you people are so genius. Yes, he is Sir Isaac Newton. And you see, When the apple fell on his head, he was wondered. He just started thinking why the apple falls down. Then he just discovered this gravitational force. He said, gravitational force is a force with which objects pull one another. And this force is a very weak force. It is the weakest force in the world. As I used to say, that the strongest force is the nuclear force when we studied the topic electricity. We can feel the gravitational force as the weakest force. It only if the object is very massive, we can feel this gravitational force if the object is very massive. The magnitude of this force depends on the masses of the two objects and the distance between them. So we can say that the gravitational force of attraction between any two objects is directly proportional to the product of their masses, and it is depending on the distance also. If the mass is more, the gravitational force of attraction will be more. So we said that the force is directly proportional to the product of their masses. But if the distance between the objects is more, the gravitational force of attraction will become less. So we say that the gravitational force is inversely proportional to the square of the distance between the masses. And you all know a stone falls towards the earth and not the earth towards the stone. This is because of the gravitational force of the earth, as the earth has more mass than the stone. It has a greater gravitational force and it attracts the stone towards itself. Thus, greater the mass, greater will be the gravitational force. Here you see, children, in this case, you are able to see that there is a U-shaped magnet. You have learned the different types of magnets. This magnet is able to attract the iron nails. And why is it able to attract the iron nails? You must know that there is a region surrounding the magnet here, which is called as the magnetic field, where the magnet gives a force of attraction. That is, this region surrounding a magnet is called as magnetic field, and this region surrounding the magnet, we can feel a force of attraction for the things that are made up of iron, cobalt and nickel. So this force of attraction provided by a magnet is called as magnetic force. So the force exerted by magnets on each other and on metals such as iron, nickel and cobalt is called as magnetic force. A magnet can act from a distance because it is surrounded by an invisible field of a magnetic force. Just now I showed you the picture. So here you see, before we start with the third non-contact force, that is the electrostatic force, we will recall the structure of atom, the subatomic particles and the charges, what we discussed in the previously taught topics, that is electricity. You all know all atoms are made up of tiny particles called as protons, neutrons and electrons. And you know, inside the nucleus of an atom there are protons and neutrons, and around the nucleus electrons revolve around the nucleus. And you should know that electrons are negatively charged and protons are positively charged. And always in an atom, number of electrons are equal to the number of protons. So atom is said to be electrically neutral. But this is not the case always. These atoms, they tend to lose electrons. That is, they lose the outermost electrons which are revolving around their orbits. And this process of transfer of electrons occurs within the atoms. And you all should know that some atoms also gain electrons. So when they lose electrons, they gain a positive charge. And when they gain electrons, they attain negative charge. So these charged particles, they behave in a different manner. They start attracting with each other. So this branch of science that deals with the static charges is called as electrostatics. So electrostatics is a study of the effects of stationary charges on each other in their surroundings. Charges are created by the transfer of electrons. It is never the proton which is getting transferred. Objects with equal number of protons and electrons are neutral. They have no net charge. Objects with more electrons than protons are charged negatively, and objects with less electrons than protons are charged positively. Look at these pictures. I have taken two balloons. One balloon I rubbed it with woolen cloth. So while rubbing with the woolen cloth, what happens? There is a transfer of charges. And when I bring these two balloons together, they start attracting each other. Okay, so blue balloon was uncharged, but pink balloon was charged. So there is a force of attraction. Now, this force of attraction will change into force of repulsion when I charge the blue balloon also by rubbing it with wool, because both of them, they attain the same charges. They start repelling each other. So this type of charge which is getting transferred is called as electrostatic charge. And here is the force, electrostatic force acting on them. The force acted upon because of the accumulation of charges on these objects is called as electrostatic force. So we can say the force exerted by a charged body on another charged or uncharged body is known as electrostatic force. So before I end up the topic force, I would like to just know whether you all understood all the concepts of this lesson. Look here, there is a ball. This ball is stationary. It is at rest. Okay. So when it is at rest, what does this mean, children? Is there any force acting on this ball? Would you say yes or no? Yes, you're right. This ball is being acted upon by forces. So, this ball is being acted upon by gravitational force downwards, and an equal and opposite force is exerted by the ground on the ball, which is called as a normal force. So, here since the magnitude of gravitational force and the normal force is equal, the net resultant force will be equal to 0. And since the net resultant force is equal to 0, it is called as what type of force? A balanced force or an unbalanced force? Yes, you're right. It is balanced force. So, hope you all have understood, and I am also satisfied so much with your performance. This last question itself gives me a satisfaction that you all have understood the concepts well, children. So thank you for your cooperation and your patience to listen to my class carefully and sincerely. Thank you all, children.